Isang masayang pagbati na may ngiti sa aking mga labi. Naghahanap ba kayo ng makakatuwang sa pagre-review ng inyong anak? Meron yan sa DepEd. Ang ETUlay online tutorial ay libre at handog ng ating kagawaran sa pangunguna ng OUA ICTS EdTech. Ito ay isang proyektong makatutulong sa mga mag-aaral, katuwang ang mga magulang o kasama sa kani-kanilang tahanan para masagutan at maunawaan ang mga modules. Hangad din ng programang ETUlay ang matulungan ang ating mga guro sa kanilang mga blended learning classes. Ang ating ETUlay ay mula kinder hanggang senior high school. Bukod sa academics, meron din tayong mga special programs gaya ng All is Wellness, Reading and Math Remediation, Storytelling, Mommy Tech Talks, Classes sa Gramatika, Speech Class, Financial Literacy, at marami pang iba. Pinalawig din ng ETUlay ang ating Alive program para sa mga mag-aaral mula grade 1 hanggang grade 3. Gayun din ay mayroon tayong ALS program at SPED tutorials na makasisigurong makakamit ng lahat ang inclusive education. May SPED hotline na rin para sa inyong mga katanungan patungkol sa special education. Kaya, subaybayan mula Lunes hanggang Biyernes, mula 9:00 ng umaga hanggang 7:00 ng gabi ang ating ETUlay. Sa ating pagtutulungan, maiaangat natin ang bawat isa. Ating itutulay ang pagkatuto upang di mapigil ang pag-aaral ng kabataang Pilipino. Itulay natin ito, sulong edukalidad.
Calling all senior high school students. Let us all be super this second semester. Join your volunteer ETUlay tutors for science and technology subjects every Monday and be #Mahusay. Explore the incredible world of physical science with Tutor Lester and Tutor Nell, 4 o'clock to 4:40 p.m. Be internet smart and discover more about the different ICT tools that you can use on Empowerment Technologies together with Tutor Jane and Tutor Janelle, 4:40 to 5:20 p.m. Let Tutor Edson, Tutor Echo, and Tutor Leo guide you on how to be prepared for various hazards on disaster readiness and risk reduction, 4 o'clock to 4:40 p.m. And learn the concepts of genetics, biodiversity, anatomy and physiology, and evolution on General Biology 2 with Tutor Easter and Tutor Tina, 4:40 to 5:20 p.m. Be part of our team and be #Mahusay.
Mabuhay! Good day to all! I am your Tutor Madge. Welcome to ETUlay, a free online tutorial, an initiative of the Department of Education, Information and Communications Technology Service, Educational Technology Unit, ICTS EdTech. This program is aimed at helping and assisting learners from kindergarten, senior high school, ALS, Alive, and SPED learners. Aside from answering the modules, the ETUlay is offering programs which you will surely look forward to. Together with our parents and teachers, the ETUlay will bridge the gaps where difficulty and ease meet in learning new knowledge and skills. So, let us prepare our modules, pen and paper. Ready your mind to see and hear worthwhile and interesting lessons. Let us now study and learn, together with our volunteer online tutors. Tara na!
Good afternoon, Sir Tutor Neil.
Good afternoon, Tutor Lester, and good afternoon ating mga viewers.
Alright, so isang #Mahusay Monday afternoon sa ating lahat. So once again, good afternoon, Tutor Neil. So welcome to week number 6 sa paksang stoichiometry.
Yan, good Monday afternoon din po, Tutor Lester. And syempre, good Monday afternoon sa ating mga nanonood from Luzon, Visayas, and Mindanao. Isang mainit na pagbati sa ating mga partner schools na walang sawang sinusuportahan ng ating physical science live sessions dito sa DepEd ETUlay. Welcome to another week of new learning.
So hopefully kayo po ay nakapagpahinga at nakapag-unwind during the weekend para na naman sa isang linggong pag-aaral kasama kami dito sa DepEd ETUlay. So as usual, kami po ay nananawagan sa inyo para i-share itong ating live session natin sa physical science para mas marami tayong maabot ng mga mag-aaral na kailangan ng gabay sa kanilang pag-aaral sa kanilang mga self-learning modules sa physical science. So ito po ang inyong mga Tutor Lester from SDO Ormoc City.
And ako naman po si Tutor Nel from SDO Pasig City.
We are at your service.
Yes. Now, congratulations po sa ating mga partner schools na papangalanan natin ngayong araw. Kami pong mga tutor ay lubos na nagagalak sa inyong walang sawang pagsubaybay at pagsuporta sa ating live session kada Lunes. Patuloy lang po tayo sa ating pagsuporta upang mas maging malawak ang maaabot ng ating live session. Do not forget to like and share. Anyway, Tutor Lester, ano po ang ating mga partner schools for week number 5?
Alright. So congratulations po to our following partner schools. Dahil sa inyo, ang modular distance learning ay nagiging #mahusay. So we have the following schools. Padre Garcia National High School, Caibiga High School, Alibadabad National High School, Tumawini Stand-Alone Senior High School, Luis P. Gomez Diamantina National High School, and Jones Rural School.
We also have Aurora Senior High School, Ipil National High School, Buting Senior High School, San Mariano National High School Main, Pasay City North High School, Godofreyo Reyes Senior National High School.
At ngayon naman, I will once again do the honors in introducing our students of the week for week number 5. Alright. So for this week po ay nadagdagan po ang mga schools na maitatampok natin sa ating students of the week. So hindi na po natin papatagalin. So ito na po sila. And still from Tumawini Stand-Alone Senior High School, ang ating dalawang #mahusay na mag-aaral na student of the week natin from week number 3. So we have Joan Taguba, Diane Joy Di Madayag, and our new student of the week from the same school, Joan Dilaman, Germaline Domingo.
And we also have ang ating new addition for the week is from Alibadabad National High School. Congratulations po to Princess Purificacion, Lorenzo L. Domingo Jr., Edward Ladit, Vanessa Tibalog, Mikaela Sumikkay, and Christina Zipagan. We also have from Ipil National High School, Jessa C. De La Cruz. And lastly, from San Mariano National High School, we have Jo Marie Sibal. Once again, congratulations po sa ating mga student of the week. Nais nyo rin bang ma-feature dito sa ating physical science live session? Huwag kalimutang i-share at mag-submit ng inyong mga output sa activity na aming ibibigay mamaya bago matapos ang ating session.
And now let us honor our teachers of the week. So congratulations mga teachers dahil #mahusay ang mga teachers ay sadyang #mahusay din ang mga mag-aaral. So our teachers of the week. Okay, consistent po. Our teacher from Tumawini Stand-Alone Senior High School, teacher Florife M. Narag. And our new addition from Alibadabad National High School, teacher Irma Malsi Manuel. And lastly, from San Mariano National High School, teacher Leo S. Galisa. So, congratulations po mga ma'am and sir. So, naway magpatuloy po ang inyong pagsuporta sa ating Physical Science ETUlay live session at pati na rin of course sa iba't ibang asignatura dito sa DepEd ETUlay. So, once again, isang virtual clap po para sa ating mga students and teachers of the week. Yan.
Ayan. Ngayong week, ang most essential learning competency na covered natin ay determine the limiting reactant in a reaction and calculate the amount of product formed.
Before we move on to our discussion today, i-recall muna natin ang pinag-usapan natin last week. So, nung nakaraang live session, we talked about chemical reactions. So, narito ang ilan sa mga importanteng konsepto na napag-usapan natin last week. So, for a reaction to happen, substances or particles of reactants must physically collide with enough energy. Particles of reactant must come into contact or collide in the correct orientation. Activation energy is the maximum energy required for a reaction to take place. And catalyst is a substance which speeds up a reaction.
Now, let us get started with the topic. Chemical equations give the ideal stoichiometric relationship of reactants and products. However, sometimes the amounts of reactants used are not mixed in exact or proper ratio. Ibig sabihin, after the reaction, may mga reactants na sobra at meron din namang nauubos. For this session, let us first define the key terms that we will be using. Simulan natin sa stoichiometry. We have already encountered stoichiometry during our junior high school science, specifically sa chemistry. Stoichiometry establishes mole and mass relationship between reactants and or products in a chemical reaction to determine the desired quantitative data. Ang stoichiometry is more of the ratio of the quantities ng reactants that takes part in a reaction. Stoichiometry sets kung ilan ang quantity ng bawat reactants. After a chemical reaction, there will be some reactants that will be left unreacted. Ito ang tinatawag nating excess reagents. Ito yung mga reactants na hindi nagamit during the chemical reaction at andun pa rin after the products are formed in the chemical reaction. The limiting reagent naman is completely used up in a chemical reaction. Matapos ang chemical reaction, ay wala na tayong makikitang bakas nito. And now that we have defined the key terms in this topic, let's discuss the essence of this session, the stoichiometric calculations.
All right. So the first step in stoichiometric calculation is to balance the chemical equation. Mahalaga ang balance equation dahil ang ratio ng mga reactants which are based on stoichiometric coefficients will be used in the computation. Mali ang computation kapag nagkamali tayo sa stoichiometric coefficients. Ang nakikita nating reaction ay hindi pa balance. Alright. So this is a reaction where propane or C3H8 is born in the presence of oxygen to produce water and carbon dioxide. So what are the steps to balance the equation? Ang pinakaunang gawin ay dapat isulat ang equation gaya ng nababasa niyo po dito sa slide. Then, the second step, write down the numbers of atoms per element. So maaari nating isulat sa isang table ang number of atoms na makikita natin sa reactant at product. Kung ano ang subscript na katabi ng isang atom, ay yun ang number nito. In the equation, we have the following numbers. Carbon from the reactant side, we have 3, and in the product side, we have 1. Oxygen in the reactant side, Okay, we have 2, and in the product side, we have 3. Hydrogen, we have 8 in the reactant side, and in the product side, we have 2. Makikita natin na hindi pantay ang number of atoms. So, in order to balance the equation, we have to balance the number of atoms in the reactant and the product side. Let us remember that we cannot change the subscript. Hindi po natin pwedeng baguhin ang subscript ng atom which is found in the equation. So in order to balance the whole thing, we need only to add a coefficient beside the atom. We balance the other atoms before balancing hydrogen and oxygen. So we will start with carbon. So in the reactant side, we have 3 carbons, while on the product side, meron lang pong isa. So how do we balance carbon? So from our live viewers po, paano natin ibabalanse ang carbon? Alright, Tutor Neil, paano po ba natin ibalanse ang carbon?
Ayan. To balance carbon, we add a coefficient to the single carbon atom in the product side to balance it with the 3 carbon in the reactant. That 3 carbon in the product side changes the number of oxygen in the same side as well. Our oxygen now is 7 in the product side and 2 on the reactant side. Do we need to balance it now or balance hydrogen first? Yes, we need to balance hydrogen first and then deal with oxygen later. So, hydrogen in the reactant side has 8, while it only has 2 in the product side. How do we balance the number? Saang banda tayo maglalagay ng coefficient to balance the hydrogen atoms? Tama. We add the coefficient 4 beside hydrogen in the product side. We multiply that coefficient with the subscript in hydrogen, which is 2. Does this balance the number of hydrogen atoms? Yes, it does. Hydrogen atoms in both sides of the equations are now equal to 8. And lastly, we balance oxygen. Ilang oxygen atom on the reactant sides and on the product sides ang inyong nabibilang? Ayan. This is not balanced because there are 2 on the right side and 10 on the product side. How do we balance the oxygen atoms? Tama. We need to add coefficient of 5 beside oxygen in the reactant side and multiply that to the subscript in oxygen, which is 2. Finally, balancing the equation. Ang nababasa po nating chemical reaction sa slide ay ang balance equation na po. Now that we had balanced the reaction, we can now proceed to the next part.
We had balanced the reaction, and the next thing to do is finding the limiting reagent in the reaction. We have here the example problem. Excuse. For the following reaction, what is the limiting reagent if we start with 2.8 grams of aluminum and 4.25 grams of chlorine? In the problem, we have aluminum and chlorine as the reactants. We write down the reactants in an equation form. What does aluminum and chlorine form? From what we had learned during our junior high school chemistry, aluminum and chlorine produces aluminum trichloride. So this is now the written equation. Next thing to do is balance the equation. So we balance the aluminum first, followed by chlorine. Right? So add coefficient 2 to aluminum, and add 2 coefficient to aluminum trichloride and add 3 coefficient beside the chlorine, so that balance the reaction.
Ayan. Now that we had balanced the chemical reaction, we convert the grams of aluminum and chlorine as stated in the problem into moles. We check the periodic table for the formula mass of aluminum. Aluminum is equal to 26.98 grams, which means a mole of aluminum is equal to 26.98 grams of it. So, we multiply the number of grams of aluminum as mentioned in the problem to the ratio of 1 mole per 26.98 grams aluminum, canceling the grams. Therefore, in 2.80 grams of aluminum, there is 0.104 moles aluminum. Now, you need to do this process for chlorine. Get the formula mass of chlorine gas, which is 70.90 grams, which means 1 mole of chlorine gas, which is Cl2, has a mass of 70.90 grams. Use this ratio to convert the given mass, which is 4.25 grams, to its equivalent number of moles. After solving, 4.25 grams of chlorine is equal to 0.0599 moles of chlorine gas.
From the conversion values, we list the number of moles per reactant as follows. Aluminum, 0.104 mole. Chlorine gas, 0.0599 moles. So what's next? We haven't determined yet kung alin sa dalawa ang limiting o ang mauubos after a reaction at ang excess o ang sobrang reactant matapos ang reaction. There are ways how to determine the limiting reagent in the reaction. All right, Tutor Nell, what's next?
Yan. Method 1 of finding the limiting reagent is to use the stoichiometric ratio of the reactants from the balanced reaction or equation. We calculate the actual molar ratio of the reactants, then compare this ratio to the stoichiometric ratio from the balanced reaction. The actual ratio to the moles of aluminum divided by the moles of chlorine. That means the actual ratio that we have is 1.74 moles of aluminum for every mole of chlorine. Ano po ang kasunod nito, Tutor Lester?
So now that the actual ratio of moles of aluminum to chlorine is computed, so let us now get the stoichiometric ratio of aluminum to chlorine gas. In the balanced reaction, there are 2 moles of aluminum to every 3 moles of chlorine gas. We divide 2 by 3 and we find that in every mole of chlorine gas, there is a corresponding 0.67 moles of aluminum. So that means 0.67 moles of aluminum will react with a single mole of chlorine gas to form aluminum trichloride. So that means that 0.67 mole of aluminum will react with a mole of chlorine gas to form aluminum trichloride. So as computed, there is an actual 0.104 mole of aluminum. So how much mole of chlorine is required? Okay, remember, so we only have 0.0599 moles of chlorine available. So if we try to compute through ratio and proportion using the ratio that 0.67 moles of aluminum is required to react with a mole of chlorine gas. So we have here the ratios. 0.67 mole aluminum over 1 mole of chlorine gas is equals to 0.104 mole aluminum over, okay, mole of chlorine gas. Okay, the mole of chlorine gas is unknown. So that is what we are going to find out. So cross-multiply po natin. Okay, so cross-multiply. So we have here 0.104 mole of aluminum is equal to 0.67 mole of aluminum multiplied by the unknown moles of chlorine gas. So to rewrite the equation, we divide both sides by 0.67. So ito na po yung ating rewritten equation. So a mole of chlorine gas is equals to 0.104 mole aluminum divided by 0.67 mole aluminum. So computing the, okay, get the quotient, and we have 0.155 mole of chlorine gas. All right. So therefore, we need 0.155 mole of chlorine gas to react with all the aluminum reactants. So that puts the aluminum as the excess reagent dahil sobra ang aluminum. Alright, we remember we only have 0.0599 moles of chlorine gas available, which means that we ran out of chlorine before all the aluminum is reacted, making chlorine as the limiting reagent.
Now, there is another way to find which is the excess and the limiting reactants. We try to choose one as if it is the limiting reactant. Here, we assume aluminum is the limiting reactant. So, we try to calculate the required amount of chlorine that is required to react with aluminum. So, that will be 0.104 moles of aluminum times the mole ratio between the two, that is 3 moles of chlorine gas over 2 moles of aluminum. That will give us 0.156 moles of chlorine gas. Yan. And we find that for every 0.104 moles of aluminum, we need 0.156 moles of chlorine gas. Not the same, but very close to the amount that we came up with using the ratio and proportion. So, yun nga, based sa ating computation, ay mauubusan tayo ng chlorine bago pa magamit ang lahat ng aluminum. Now, the third method is the use of the concept of a mole of reaction. In the third method, 1 mole of reaction is equal to the number of moles given by the coefficients in the balance equation. 1 mole of reaction is occurring when 2 moles of aluminum reacts with 3 moles of chlorine to produce 2 moles of aluminum chloride. We convert the moles of each reactants to moles of reaction. For aluminum, we divide the actual mole of aluminum, which is 0.104 mole, to the moles of aluminum per balance equation, which is 2. So that will be 0.104 divided by 2 moles. We'll end up with 0.0520 mole reaction of aluminum. We convert the moles of each reactant to the moles of reaction. For chlorine naman, we divide the actual mole of chlorine, which is 0.0599 moles, to the moles of chlorine per balance equation, which is 3. So that will be 0.0599 divided by 3 moles. So we'll end up with 0.0200 mole reaction of chlorine. The more moles of reactions you have, the more times the reaction can happen. Therefore, the reactants with fewer moles of reaction is the limiting reagent, since the reaction can be carried out fewer times with that reactant. We see that in this method, also chlorine gas is our limiting reagent because it makes 0.0200 mole reaction, which is less than 0.0520 moles of reaction from aluminum.
Now that we know the limiting reagent, we can use that information to answer the following question. What is the theoretical yield of aluminum trichloride that the reaction can produce when we start with 4.25 grams of chlorine gas, our limiting reagent? We can use the moles of limiting reagent plus the stoichiometric ratios from our balanced reaction to calculate the theoretical yield. The coefficients from the balanced reaction tells us that for every 3 moles of chlorine gas, we should make 2 moles of aluminum trichloride. Therefore, the theoretical yield in moles is, right, we have 0.0599 moles of chlorine gas multiplied to the ratio of 2 mole aluminum trichloride to 3 moles of chlorine gas. So we have 0.0399 moles aluminum trichloride. And since the theoretical yield is expected to have units of mass, so we convert the moles of aluminum trichloride to grams using the molecular weight of aluminum trichloride. We multiply the theoretical yield in moles of aluminum trichloride with the molecular weight of aluminum trichloride, okay, which is broken down as follows: 26.98 from aluminum and 35.45 for chlorine. And remember, we have 3 chlorine atoms. So that gives us 133.33 grams. So the theoretical yield of aluminum trichloride in grams is equal to 5.32 grams aluminum trichloride.
Now, we need to get the percent yield. Why do we need to get the percent yield? Remember that the theoretical yield is the maximum amount of product you would expect from a reaction based on the amount of limiting reagent. In practice, however, chemists don't always obtain the maximum yield for many reasons. One is purification. Since chemists know that the actual yield might be less than the theoretical yield, we report the actual yield using the percent yield shown as the equation below. So that will be actual yield over the theoretical yield times 100%. Let's have this problem. The decomposition of magnesium carbonate forms 15 grams of magnesium oxide in an experiment. The theoretical yield is known to be 19 grams. What is the percent yield of magnesium oxide? So in this problem, the theoretical yield is already given. In some cases, where the theoretical yield is not expressed, we have to calculate for it using the steps that we have had demonstrated earlier. So, to calculate the percent yield, that will be 15 grams of magnesium oxide, which is the actual yield, over 19 grams of magnesium oxide, which is the theoretical yield, multiplied by 100%. So the answer will be 79%.
All right. So, batiin muna natin, Tutor Nel, ang ating mga live viewers habang actually, it was already revealed pero i-reveal natin mamaya uli ang inyong activity. So, once again, pasensya po kung hindi po namin kayo agad nababati o kaya nababasa ang inyong mga pagbati sa comment section dahil po nakatutok kami sa delivery ng ating tutorial session. So, Tutor Nel, ikaw po muna bumati sa ating mga live viewers.
Ayan, so shout out kay Irish de la Cruz from San Miguel National High School. Ayan. Teacher niya po si Mrs. Mary Joanne Aquino. Ayan, shout out din po sa inyo. We also have From San Mariano National High School, we have Joanne Pasicolan Anes. Yan. So, good afternoon. Yan. Yung San Mariano National High School, lagi nating partner schools yan since week number 1. And we also have from Jones Rural School, Marisol Bulan. Ayan, good afternoon po sa inyong lahat. And Joshua Obado Kasidsid from Buting Senior High School. Yeah, he's my student. Yeah. Good afternoon.
Alright. So, binabati ko po ang lahat ng aking mga estudyante sa physical science na nanonood po ngayon dito sa ating live session. So, magandang hapon po sa inyo lahat at pati na rin po sa lahat ng nanonood dito sa ating live session sa physical science. Alright. So, actually, na-ipresenta ko po ito kanina by accident and now, okay, I'm presenting to you again your activity for this week. So, your activity for this week, right? So, consider the following reaction. Okay, the equation has already been balanced. Okay, na-i-balance na po ang equation. So, all you have to do is answer the following questions. For letter A, when 3.22 moles of aluminum react with 4.96 moles of hydrogen bromide, how many moles of hydrogen gas are formed? And letter B, what is the limiting reactant? Okay, so paki-screenshot lamang po if you are using a mobile phone or a laptop. Kung wala naman po, okay, you may go over the the recording later dito sa DepEd ETUlay and you may write down the problem. Okay.
Ayan. You may submit your output po in any digital format sa link na nakikita nyo sa inyong mga screen. So that will be https://bit.ly/351fi2j. Enter your name, your grade and section, the name of your teacher, school and SDO, and upload your output to be recognized. The output can be in any format possible like Word, PDF, or JPEG. Hihintayin po namin ang inyong mga submissions, mga live viewers.
And just a reminder lang po, for the files na i-upload nyo po, kindly use the format last name _ first name para mas madali pong makilala kung sino po ang nag-send sa amin ng mga output. Dahil the outputs that are being submitted are also being read to be considered for the student of the week. Alright, so ulitin ko po, use the file name format, last name _ first name.
So, all right, that's a wrap. No? Let us summarize everything that we discussed today. The limiting reagent is the reactant that gets used up first during the reaction and also determines how much product can be made.
We can find the limiting reagent using the stoichiometric ratios from the balanced chemical reaction along with the many methods.
Once we know the limiting reagent, we can calculate the maximum amount of products possible, which is called the theoretical yield.
Since the amount of product is often less than the theoretical yield, chemists also calculate the percent yield using the ratio between the experimental and theoretical yield. And ngayon, dumako na naman po tayo sa ating quiz segment na Gets Mo, Sagot Mo. So, may sasagutan po tayong 5 katanungan na po lamang taken from what we had shared to you earlier. So once again, we are inviting you, our live viewers, to join us in our segment. So paki-comment na lamang ang inyong mga sagot dito sa ating comment section. Alright, so let's get started.
Number 1. This refers to the reactant that is all used up after a reaction. A. Limiting reactant. B. Excess reactant. C. Percent yield. D. Cofactor. The answer is letter A. Limiting reactant. Number 2. Which of the following describes the relationship of the number of moles and mass of reactants and products in a chemical reaction? A. Molality. B. Percent yield, C. Stoichiometry, D. Balancing equation. The answer is letter C. Stoichiometry. Number 3. It is the maximum amount of products you would expect from a reaction based on the amount of limiting reagent. Letter A. Excess reactant, B. Theoretical yield, C. Limiting reactant, letter D. Product difference. The answer is letter B. Theoretical yield.
4. This refers to the reactants which were not used up after completion of a chemical reaction. A. Solute, B. Solution, C. Excess reagents, D. Limiting reagents. The correct answer is letter C. For number 5, in the equation magnesium plus hydrogen chloride, giving us a product of magnesium chloride and hydrogen gas, how many molecules of hydrogen chloride do we need to make hydrogen balance? A, 3, B, 6, C, 2, and D, 7. The correct answer is letter C, 2.
Ang paksa na ating tinalakay ngayong hapon ay nakabatay po sa content ng Physical Science ADM Module 10 ng Region 4A Calabarzon. Salamat po sa inyong pagsama sa aming nasa nakaraang 40 minutes na umaatikabong live session tungkol sa stoichiometry. We are inviting everyone to send us their feedback in help and us improve the tutorial session. If you are using a device with a QR code scanner, you may scan the code na makikita nyo po sa inyong mga screen. Or, you may screenshot the screen for you to scan it later. You may also type in your web browser the link displayed in the bottom area of the screen. That is tinyurl.com/ETUlay feedback form. Again, that is tinyurl.com/ETUlay feedback form.
Maaari rin po kayo maglagay ng inyong mga appreciation sa ating feedback form in the link given. You may also email your comments, suggestions through the email that you can read in your screen, edtech@deped.gov.ph.
Inaanyayahan din po namin kayo, aming mga minamahal na mga live viewers, na sabayan rin po ang ating mga tutors sa General Biology 2 na sina Tutor Easter ng SDO Caloocan City at Tutor Tina ng SDO Pasig City after this session from 4:40 to 5:20.
You may also watch the live session in Empowerment Technologies kasama ang ating mga tutor na sina Tutor Jane of SDO Puerto Princesa City at Tutor Janelle ng SDO Ilocos Sur right after this session from 4:40 to 5:20. And that's it for week number 6. So, supportahan din po natin ang mga tutor from the different subject areas sa senior high school. Huwag po kalimutan, from 4 to 5:20 in the afternoon. See you again on Monday from 4 to 4:40 p.m. And this is your tutor, Tutor Lester from SDO Ormoc City.
And yours truly, Tutor Ronel from SDO Pasig City.
Goodbye.
And God bless.
Ang husay naman! Natapos mo ang iyong tutorial session kasama ang iyong mahusay na ETUlay tutor. May bago ka bang natutuhan? I-share na yan gamit ang hashtag #ETUlayLevelUp. Huwag aalis ha dahil may susunod pang programa na pwede mo ring panoorin at salihan dahil naghihintay na ang iyong mga tutors. Happy learning dito sa ETUlay!